Thursday's lesson. And we were looking at these equations. So what I've got over here is I've got two equations. They are as difficult as equations can get. So if you're feeling okay with these equations, you will be fine. If you are new and you are looking at this and you have never seen trig equations before, please don't panic. I will go through them with you. If you are feeling quite confident at the end of the lesson on Thursday, I would love it if you tried both of these questions. And if you were feeling a little bit less confident, then maybe just try one. Okay. So if you're feeling completely lost, if you're new and you've never seen this, you can just wait, or you're welcome to give it a try. And then we're going to go through them. If you're feeling confident, do A and B. And if you're feeling a little bit less confident, just do A. So we're going to go through this, and then we're going to dive into the world of Pythagoras. It's very exciting. Or Pythagoras and trig. Okay, so give these ones a go. Try and find what theta is going to be. So remember, we're looking for theta in both cases. Ah, yes, Nokubonga. Me too. I also like Pythagoras. So if you're feeling good, give both a try. If you're not feeling so good, just give one a try. And then we'll go through these answers, and then we'll move into today's lesson. Oh, my batteries. Oh. Hello. And for those of you who weren't here when I greeted you, I hope you all had a lovely long weekend and are ready for some trig this evening. Get your trig brains on. I didn't have the top 3 learners of the quizzes from last week Thursday because too many of you got 100%. And the list was too long. So I have to write a nice list with names next to each other. So I'll put it up on Thursday. Okay, we've got our first answer coming in from for A. There's something very important missing at the end of that answer. And I'm going to go into a rant about goats again. We have to remember our units. Yes, of course. So what units are we going to put there? What are we finding when we're looking for theta?
I believe it was cheese, ma'am. That's what I remember.
Yes, either cheese or goat rat. It's one or the other.
Yes, Kosi, degrees. Awesome.
Yes. Degrees. Okay, good. Okay, I'm going to give you guys 2 more minutes. So until 6:08 to work through these, and then we're going to talk about them together. Hopefully some of it is sort of sinking in into memory from this point. So what I've highlighted is what you need to isolate before you can use your calculator. And once you've isolated that, you use your calculator and then you can solve for theta. Okay, 6:08. Let's go. Chaucy, can I help?
Ma'am?
Yes.
Is it okay if I get rid of 3 first?
The 3 at the bottom.
Yes, ma'am.
Yes, that's absolutely your first step.
Okay.
Okay. All right, so let's have a look at A, guys. First thing we want to do, exactly like Chaucer's instinct was, we want to get the 3 up to the top. So some of you said as timesing both sides by 3, so you have a 3 over here, and you times that by 3, and those 3's cancel. Or you can think of it as moving this 3 up, and because it was being divided, now it is going to be times. I don't mind how you think about it, but that's what we're doing. So we're going to have sine 3 theta minus 35 degrees is equal to 0,17 times 3. That's our first step. Okay, so I'm very curious to hear if anyone managed to get, well, let me get a number happening over here. Oh, goodness gracious. So we have sine 3 theta minus 35 degrees, and that's going to be equal to 0,17 times 3, which is 0,51. So if you got to this point over here, can you give me a thumbs up emoji, please? Some way, if you got to this point over here, just so I can get an idea of where we're at, if you were able to get there.
I'm seeing a lot of thumbs up.
Great.
It's looking good, Miss J.
Okay. Now that we're here, we have to move into our calculator. So once we've isolated our trig ratio with whatever it has next to its brackets, then we move into our calculator. Okay? And when we move into our calculator, because we're looking for an angle, we're going to say shift or arc sine, depending on what your teachers are telling you, shift sine 0,51 equals. And that's going to tell us what this bracket is equal to. Okay, so we're going to say shift sine 0,51, and we get that 3 theta minus 35 degrees is equal to 30, comma, and it's not my final answer, so I'm going to give 4 decimal places, 6638. Okay. So if we were thinking about this visually, this angle over here is my 3 theta minus 35. And I know that that whole angle is 30,66 something degrees. Okay, but I want to figure out what just theta is. So now I want to move this 35 over. Sorry guys, my pen is like having a cuckoo time today. So 3 theta is equal to 30,6638 plus 35, which means 3 theta is equal to 65,6638. And now if I want to know what just theta is, I need to divide both sides by 3. And so theta is equal to 21,89 degrees. And that is our final answer. Okay. How did this one go? Give me a number, 0 to 10. Tell me how this question went. 0 to 10. 0, absolutely awful. 10 went really well. Nice, Emmanuel. Samuel, well done. Okay. You know what, guys? Those of you getting 4s, 4 is better than 0. Okay. Cool. I'm going to keep this here as a guide, and I want you to try and think about it with this question B. So I want you to try and apply some of the stuff that we just spoke about with these yellows and oranges and apply it into these questions. If you already did B, I want you to have a look at how you did B and see if you can fix it, if you made mistakes. And if you didn't do B, I'd like you to give B a chance looking at what we've just done in yellow and orange. And my hint to you is that your first step is that you're wanting to isolate what I've got over there, which was highlighted in orange. And why aren't you converting what, Sarah? Into what though? Oh, rounding. Got you. Okay, because we always round our answer to 2 decimal places. So we always keep it as an answer with 2 decimals. Your matric exam, on the front page under instructions, it will say, leave all answers to 2 decimal places unless otherwise specified. So always in a test, unless you're told otherwise, always to 2. And in my question, this was 8, 8, 7. And so that 7 made this 8 a 9 degrees. So we did round. We just went to the 2. Kanya, can I help?
Yes, ma'am.
Yeah.
Ma'am, will we start by removing the 3 or the 2?
You can do either first. So you can either divide by 2 and then times by 3, or you can times by 3, divide by 2. Same.
Thank you, ma'am.
Sure. I'm not going to do the whole thing. I'm just going to help a little bit over here. So I want to times by 3 and I want to divide by 2. So I want to get to a point where I have sine theta minus 10 degrees is equal to 0,102 times 3 divided by 2. You don't have to write it like that. You could also have said times 3 divided by 2. Either way, however you want to write it. So before you jump into your calculator, well, I mean, you would need to use your calculator really, but you know what I mean. You should want to get to this point over here. So if you got to this point, that's really good. And now from here, you're going to move into your calculator with your shift. Good, well done. I'm so glad you got there. Okay, so from here, we're going to jump into our calculator and we're going to say shift sine 0,153 equals. That's what we're going to put into our calculator. So shift sine 0,153. And I get the answer that theta minus 10 degrees is equal to 8,8008. And I'm going to keep all 4 of those decimals until I have my final answer. Then I'm just trying to find theta. So now I just can move my little 10 across. So theta is equal to 8,8008 plus 10, which means theta is equal to 18,80 degrees. Yay, look at these right answers in the chat. Woo! Nice work, guys. A little happy mouse dance. Woo! Okay, cool. I feel good. If you are still feeling uncertain with equations, remember that the videos are on the website and you can give our videos from last week a watch and see how it goes. Sia, how can I help?
Hi, ma'am.
Hi.
I hope you're doing well. Ma'am, is that a 0?
Yes, 18,80.
Like there, ma'am, 0 equals 18,80.
No, Sia, that's theta. Theta.
Wait, oh, ma'am, sorry, ma'am.
This is what happens
Ma'am,
when you
it looks
play
like
too much soccer.
it looks like zero.
It does not. It looks like theta. Remember, theta is basically Peter. He just doesn't have a smiley face. That's Peter. That's Peter,
Okay, ma'am.
and that's theta.
Hi,
And
Peter.
that's 0. Just so we're clear. Those are our 3.
Okay, ma'am.
Okay, Portia, how can I help?
Ma'am,
Yeah.
what I did was in the first step, like the beginning, I multiplied 2 and 3 to get 6 just because I wanted to cancel them. And I think that's where I went wrong.
Yeah, that's where it went wrong. So just be careful. Remember, when it moves over to the other side of the equal sign, it has to do the opposite of what it's doing. So this 3 is being divided, which means when he moves over, it has to be times. And this 2 is being timesed, which means when he moves over, he has to be divided. So we have to think about what's happening on the left. So then when he moves over, he does the opposite thing.
Okay, ma'am. Thank you.
Okay. Okay, so that is our equations. That was Thursday's lesson. And now we are going to jump into Cartesian plane. The Cartesian plane is just this dude. Some of you will remember him. X and Y, when we have points, like the coordinates there would be, say, 2, 3. I don't know if you remember the Cartesian plane. That's a Cartesian plane. And Pythagoras, who has a theorem called the Pythagoras theorem. And we just need to quickly go over how the Pythagoras theorem works. No, we haven't spoken about reciprocals. Reciprocals are actually not in your curriculum anymore. So some schools teach reciprocals. So if you've heard of things like cot, for example, that's a reciprocal. But they aren't actually in your curriculum. So schools that do them are choosing to do them. They won't come up later. Okay. Okay, Pythagoras' theorem. How does Pythagoras' theorem work? Who can tell me how Pythagoras' theorem works? I saw a hand and then it disappeared. Ah, Chaucy. Yes, Chaucy. Hello. How does Pythagoras' theorem work?
Ma'am, it says the square of the hypotenuse
Yes.
is equal to the sum of the 2 other sides.
Excellent. Okay, so if this is A and this is B and this is C, then C squared is equal to A squared plus B squared. Okay, beautiful. Okay, now when we use the Pythagoras theorem, we have to say that we are using the Pythagoras theorem because we are fancy and we're mathematicians. So when we say it, we have to say Pythagoras and we have to write this whole schleb. We can't even just say Pythag. We have to say the Pythagoras theorem. Okay, so Canva, yes, the hypotenuse is always bigger. It absolutely is always bigger. That's why we're saying that the hypotenuse, this dude, ooh, hello, the hypotenuse is equal to the sum of our other 2. That's how big it is. What is happening over there? That's weird. Okay, so let's have a look at it in numbers, for example. Let's say that this was 4, and let's say that this was 3. Okay, and I was trying to find out what x is over there. I could say x squared is equal to 4 squared plus 3 squared because of the Pythagoras theorem, which means x squared is equal to 16 plus 9. So x squared is equal to 25, which means x is equal to 5. Okay. Is there anyone in this call who hasn't seen the Pythagoras theorem before? And if you're embarrassed, you're welcome to send me a direct message. I just need to know, this should be something that you've seen before, so I don't want to spend a huge amount of time on it. I just want to, in case anyone else hasn't seen it. Okay. Excellent. Cool. Okay. So that is if we were finding the hypotenuse. Let's assume that we did have the hypotenuse. So let's work backwards. Let's say that the hypotenuse was 5 and this side over here was 4, and I was trying to find that side over there. I was trying to find that x value over there. Okay. Then we could write it the same way. So we say our hypotenuse squared. So this is what we're writing. Hypotenuse squared is equal to one side squared plus one side squared. That's what we're doing, right? Okay, exactly how. So our hypotenuse in this case, because our hypotenuse, like Comfort said, is the longest side of a triangle opposite our right angle. So our hypotenuse is 5 squared is equal to one of our sides, so 4 squared. Let's highlight this. So our hypotenuse is 5 squared is equal to one side of our triangle, 4 squared, plus the other side of our triangle, squared. So 25 is equal to 16 plus x squared. 25 minus 16 is equal to x squared, which means 9 is equal to x squared, and so x is equal to 3. So that's telling me that that side is equal to 3. And that is Pythagoras in a nutshell. So Pythagoras is just saying that the sum of two sides squared is equal to our hypotenuse squared. And if you're still feeling a little bit uncertain with Pythagoras, don't panic. We're going to be dealing with it a lot in the questions today. So don't stress. It's just one part of the things we need to talk about. Okay. So this is Pythagoras. Sibonginkosi. I really messed up your name. Sibonginkosi. I'm messing up your name terribly.
If you just say Sibongi Nkosi, I think that is what.
Sibonginkosi. Oh,
There we go.
thank you. Thank you, Coco.
Can I ask that Pythagoras works only in a right angle?
Yes, absolutely. Pythagoras only works in a right angle triangle.
Okay, thank you.
You're most welcome. Olotando? I can't hear you if you are speaking. I see you're unmuted.
Olotando, can you check your mic settings, please? Make sure that your output is something that we can hear. You can hear from.
Can you hear?
Yes, yes.
Yes, ma'am. I wanted to ask if it's okay to write one side equals to hypotenuse minus one side.
Absolutely. Totally fine.
Okay, thank you, ma'am.
No problem. Okay. So that was Pythag. That's the first part of our lesson. Now we move into the Cartesian plane, and then eventually we're going to combine them into one thing. Okay. We'll see. We'll see how it goes. The Cartesian plane is a way for us to be able to do trig on triangles that don't look like they are right angle triangles. So remember when I started teaching you trig, I said trig has to be on a right angle triangle. This is a way where we can sneak around that rule. And the reason we can sneak around that rule is because if I have a point on a Cartesian plane, I can always create a right angle triangle. Doesn't matter where I am. I can always create a right angle triangle. So by using the Cartesian plane, I can have points that go all the way around. It doesn't matter where they are, because wherever it is, I could make a triangle. And if I can make a right angle triangle, I can use trig to find either angles or sides. So we use the Cartesian plane as a way to cheat around the rule of having it only be right angle triangles that we can use with trig. Now, the nasty thing with that is that we have to think of sine, cos, and tan in a slightly different way. So I'm going to draw this little triangle over here. Okay. We're going to think of it as this angle here being theta. Okay. Now, if that angle over there was theta, what would this line over here be? Would that be A, O, or H? This line here. Good, 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 guys. Well done, well done. That would be O. Okay. What would this line down here be? Good, Kelly. Yes, this line down here would be A. And this line up here is our longest line of our triangle, the line opposite our right angle, which would make this one H. Okay, cool. So we know, because we're very smart, we've got SOHCAHTOA. So sine is equal to SOH, cos, ca, tan, over. Okay, so we've got SOHCAHTOA. Now, instead of O's, A's, and H's, we need to think about it in terms of X's and Y's and R's. So now we're going to think of it instead of A, O, and H, we're going to think of it of X, Y, and R. R is always going to be your hypotenuse. It's always going to be this line over here. That's always, always, always going to be R. Okay, so whatever that line is going to be, it's going to be R. And it doesn't matter where it is in the Cartesian plane, it's always going to be positive all the time. Okay, so instead of H, we're going to think of it as R. We're going to think about this line as an R. Now, I want you to think about a Cartesian plane. This line over here, this point, this is on the x-axis, right? So this distance over here, is that going to be x or is that going to be y? That distance over there, where that A is. Good, Nkosi. Yes, yeah, nice, good. So this is our x value because it's on our x-axis, okay? And this value up here, that's parallel to our y value. This value up here, that's our y value up there. And so that is our y. So what we land up seeing is that sine is actually, when we do x, y's, and r's, y over r. Cos is going to be x over r. And tan is going to be y over x. Now, personally, I find those quite difficult to remember, okay? But drawing a little triangle like this is not a difficult thing to draw. And then you're always able to see where your x is, where your y is, and where your r is. And you're able to write your new trig ratios in terms of x, y's, and r's. So use this little table when you need to help you. So let's say you're in a test. We all know SOHCAHTOA now. So you can write SOHCAHTOA. You just draw yourself a very quick Cartesian plane. See, that took me 10 seconds. That's x, that's y. Draw yourself a little triangle. Put in your theta. Think about what these would be. H, A, O. And then think about what they would be in terms of x, y, r's. X, y, r. And then you can see that wherever you have an A, you would have an X. Wherever you have an O, you would have a Y. And wherever you would have an H, you would have an R. And you can just substitute it into the formula. Okay. Anyone have any questions about this Cartesian plane situation before we start combining it with Pythag? Mahal, how can I help?
Is it important to
actually write the R, Y, and X?
It's important to know this. So if you're able to just know that, if you're able to know what those would be, you don't need to draw this picture at all. But it is important to know what sine is, what cos is, and what tan is in terms of X, Y, and R.
Oh, okay, ma'am. Thank you, ma'am.
Famelo. I think you need to unmute.
Hey,
Okay, I'm not too sure what's going on with sound there. Okay, yes, mixed emotions about this topic is fine. I can completely understand mixed emotions about this right now. I understand. I'm like throwing information at you. And if you haven't seen this before, I can only imagine that your eyes are getting bigger and bigger and bigger. But just remember that the second time you see this, the third time you see this, the more comfortable you'll feel. So like those people who did it in class, they'll feel a little bit more comfortable today. If you're still doing this in class, when you see it in class, you'll be like, okay, and it will start coming together. It just takes time. Maths is just about time. Okay, so we're going to start by just looking at something quite simple. Okay, I'm going to work through some of it with you. And then I'm going to let you try do some of this by yourself. So we're just going to start with something very simple, and then we're going to try and bring in some things ourselves. Okay. Yeah, Kelly, it's always going to be like that. And when that point starts moving, I'll show you what happens. Okay, so first things first. Oh, sorry, Georgia, do you have a question?
Hello, ma'am. Sorry to disturb you, but so could you please go back to the first slide? I was a little bit late, so can I please take a screen?
Yeah, if you can take
Thank
it
you,
in 10 seconds. Take, and then I'm going to move down. Okay, so let's have a look. First thing we want to do is we want to try and orient ourselves. So we want to know what's bottom. Okay, we need to get our heads calm into a nice, calm mathematical state. So we're going to think about everything we know. We know SOHCAHTOA. We know SOHCAHTOA. That's the first thing we're going to do. Okay, we're going to fill it in this little picture here. O-A-H. Cool. Now we're going to think about our x, y's, and r's. This would be our x value. This would be our y value. This will be our r value. Okay, we've already made huge progress. Now we think about our SOHCAHTOA in terms of x, y's, and r's. So now S is going to be y over r. Cos is going to be x over r. Tan is going to be y over x. Second thing, we're super calm still. Great. Now we have a look at the numbers that we've been given. What is that 6 and what is that 8? Is the 6? What is the 6? What is it? Is it x, y, or r? This guy. Is that x, y, or r? Think about how your coordinates work. I know we haven't been into Cartesian plane in a while. Yeah, okay. So your coordinates, whenever you have a coordinate, let's say we had 2 and 3, it's always x first and then it's y every time, okay? So that means that my x value is 6. Okay, so we already know another piece of information. We know that x is equal to 6. What is this 8? Is that y or r? Y, yes. So we know that y is 8. Okay, good. So we know that this side is 6. We know that this side is 8. How do I find the side of a triangle, a right angle triangle, when I have two other sides, what do I use? If I've got two sides of a right angle triangle, yes, I use the Pythagoras theorem. Okay, so I'm trying to find out what R is, and I'm going to use Pythagoras to find out what R is. So I'm going to say 6 squared plus 8. Well, let me write it the other way for those. R squared is equal to 6 squared plus 8 squared Pythagoras, which means R squared is 36 plus 64. R squared is equal to 100, which means R is equal to 10. And we have combined Pythagoras and the Cartesian plane and trig. So now all three of them are in one big question like this. So before we could start answering anything, we had to do all of this work. But remember that these types of questions would be worth a lot of marks because they know you have to do a lot of work. Okay. All right. So that's our first step. Now we get to do the easy stuff. This was all the hard work. Once you've done the hard work, you get to do the easy work. I want you to tell me what you think my answer will be for sine theta. What would be my answer for sine theta? I'm going to tell you that it'll be a fraction. Yes, absolutely. Because sine theta is y over r. And our y value is 8 and our r value is 10. You don't even have to simplify it. You can leave it as 8 over 10. That's it. That's what sine theta is equal to. That's great. Yes, good. Okay, let's try another one. And then I'm going to let you try some by yourself. I want to know what cos theta is going to be equal to. Yes, cos theta is x over r. X is 6, r is 10. So cos theta is going to be 6 over 10. Done. Glorious. Okay, so you have done those two. So now I want you to focus on C, which is tan theta. And then I want you to give D a try. I'm not too worried about these ones. Let's leave these ones for the moment. So I want you to try C, and then I want you to try D. And then we'll move into a question, which will be more like what you would see in a test. I think we might try and sneak our puzzle in first. Okay, I'm seeing some good answers coming in. Okay, so C, that's tan. Tan is equal to y over x. Y is 8, x is 6. So tan is going to be equal to 8 over 6. You can simplify the answer, but you don't have to. For D, we have to do a little bit of work. D, it will be easier if you don't write it as a fraction like this. So if you rather write it as sine theta divided by cos theta, and you think about what we have to do when we divide fractions, that should help. Hlalefo, how can I help? See, it's not so bad, guys. It just takes time to settle, but it's not so bad once it all comes together. Okay, let's try. So we know sine theta because we've actually already worked out sine theta. Sine theta is 8 over 10. And cos theta we've also already worked out as 6 over 10. So we're going to divide it by 6 over 10. What do we do when we divide fractions? What do we do? Josie?
Ma'am, you multiply
I multiply and what?
and take the bottom and put it to the top. I mean, you
Good.
switch.
KFC, guys. KFC. Who remembers? Who was with me last year? 8 over 10 times 10 over 6. My 10s are going to cross cancel and I'm left with 8 over 6. And if you simplified that and you got 4 over 3, that is also 100% fine. And that is this introduction to Pythagoras and the Cartesian plane. Not so scary, I'm hoping. KFC is for when we have to divide fractions. K stands for keep. So we keep the first fraction, we flip the second fraction, and we change the sign. So we only use KFC when we divide fractions. Oh no, Mahal! And there's so much on the screen. Kentucky Fried Chicken. Yes, so cosec is another reciprocal. So if you're learning reciprocals in school, you absolutely can use reciprocals. Okay, so specifically at D, if we have a look at D, okay, sine theta over cos theta, it's really useful to just always keep in mind that when we have something over something, it's the same as divide. So just another way of writing sine theta over cos theta is sine theta divided by cos theta. That means the same thing because we're dividing. Okay, we already knew that sine theta was 8 over 10 because we worked it out. So that's 8 over 10. We knew cos theta was 6 over 10. So that's 6 over 10. Then we had a divide, and when we divide in fractions, we need to change it to times, and we need to flip the second fraction. We haven't done that since grade 9. And then when we flip it, we would cross simplify, so those 10s are going to cancel, and we're just left with 8 over 6. But at this point over here, you could also put that into your calculator because they're not checking your fraction understanding. They're checking that you know how to do it in trig. Yeah, Mahal, what's your question?
Why do we why do we have to flip it, ma'am? Maybe I'm confusing this. If I remember right, the rules of fractions, if the bases are the same, you just look for something at the top.
Only for plussing and minusing, sweetheart.
I knew that I'm confusing something. Thank you, ma'am.
You're welcome. Okay. We're gonna zoom into, we're gonna do a quick question. It's an easy one today. We're just gonna quickly try and debrief our brains with this question. And once you have figured this one out, we'll get into it. We'll do one big question, like one trick question. No. Oh, there, Nkosi. Yes. Oh, so fast. Zandasile, yes. Portia, yes. Zanele, yes. Too easy tonight. But it needed to be because you're doing really hard work. So I thought I should give your brain a bit of a break. Let's quickly go through this for those of you who are struggling. Your smiley faces, they're each 10 because 10 plus 10 plus 10 is 30. There are 2 smiley faces down here, which means that's 20. Okay, 10 plus 10. 10 plus 10 is 20, and I need to get 25, which means my little devil face is 5. 5, 5. 5 plus 5 is 10, which means that the heart emoji is 7. And there are 2 of them down here, which means it's 14. This is 5. 5 times 20 is 100. 100 plus 14 is 114. Done. Okay, let's try and sink our teeth into one sort of tricky trig question and work our way through it and see how it goes. Okay, let's see how it goes. It was too easy. I want to see which one I want to do. Let's do this one. Okay, so this is the way that this question could be asked in a test situation. Okay, so this is exactly how it could be asked in a test. There's nothing sort of crazy about it. It's a little bit different because now our theta is in a different space. Okay, so in our last questions, our points were over there and now my point is over here, but I want you to think about it in the same way. I don't want you to panic. Okay, we're going to talk about this step by step again. First thing we need to do is we need to think about, oh, sorry, Rafael, do you have a question?
Yes, ma'am. I was asking if this one is it the one that you state the reason after getting the answer. Like if you get the answer here, you say angles on a straight line.
No, no, that's only in geometry.
Okay, ma'am. Thank you.
Okay. Okay, so now our theta is like this big angle. But remember in trig, we need to keep things as a right angle triangle. So we're going to think about this as our triangle like that. Okay? And we're going to break this up step by step. I want you to think about it. What is that guy? I want you to think is X, Y, or R. What is that guy? X, Y, or R? Good. Good, good, good. Nice. R. Good. Okay. And we also think about it as our H. Okay. Good. What is this guy? X or Y? Yes. X. And we think about it as A. And so that means that this guy over here is Y, that we think about as O. Okay? So I'm just going to write our thingies here. So SOHCAHTOA, sine is O over H, which means sine is Y over R. Cos is A over H, which means cos is X over R. Tan is O over A, which means tan is Y over X. And these are what we are going to think about as we work through this question. Okay, cool. So far, what information do I have? I need to have an X value, I need to have a Y value, and I need to have an R value. What is my X value? What is my Y value? What is my R value? Who can tell me what? So have a look at the information they've given you and tell me what you can tell me. Zandasile, yes, what can you tell me?
Ma'am, I think x equals to negative 12.
X is absolutely negative 12. Well done. Good. Excellent. Tell me something else. Canva, what can you tell me?
Remember
Emmanuel?
to
Oh, there we go.
The equals to 5.
Good. The Y value is equal to 5. Excellent. And now we need to find our R value. Now, in order to find our R value, okay, so we know that our Y value is 5. We know that our X value is negative 12. We can think about it as 12, but negative 12. How would I find my R value now? What do I need to use? Pythagoras. Yes. Okay. So r squared is equal to negative 12 squared plus 5 squared because of Pythagoras, which means r squared is 144 plus 25. R squared is equal to 169. Therefore, r is equal to 30. And now I have x, y, and r. I've done all my hard work. Pythagoras. Okay, so A is saying calculate the length of OP. We've just done that because we're geniuses. OP is R, and we've just found R. So we can then say in all of this work that we've done, therefore OP is equal to 13 units. Okay. Calculate the value of the 3 trigonometric ratios of theta. What are my 3 trigonometric, guys, it's this word that I struggle with. What are our 3 trig ratios of theta? What are they? Feliciwe, what are our 3 trig ratios?
Ma'am,
Yes.
I was asking if we wrote here 13, don't you say R is equals to 13 units?
Yes,
including
that's why.
to say such that OP is equals to 13 units.
So you don't have to put the units on R, but you're welcome to, but you have to put it when you say 13 for OP.
Okay.
Okay.
Sure.
Emmanuel, I see your hand was there. Can you tell me what my 3 trig ratios are that I have to find?
Ma'am, the 3 trig ratios are sine, cos, and tan.
Yes, we are needing to find. So for B, I need to find out what sine theta is. I need to find out what cos theta is, and I need to find out what tan theta is. So I want you to find out what those 3 answers for me are. We have all the information you need. Everything that you need is on the screen. I hope that for some of you who this is not the first time you're seeing it, I'm hoping that that's feeling like it's sinking in slowly. And for those of you who it is the first time, it's feeling a little bit less scary. And I want you to have found your 3 trig ratios. Put them in the chat for me so I can see if you're on the right track. Now, signs are going to be very important for us. Okay, good answers coming in for sine. So sine is y over r, which means it's going to be 5 over 13. Sine 5 over 13. So we're going to try and keep track of who gets 1, 2, or 3 out of 3 in this question. Oh, no, Kobonga, it will. It will. Remember, it takes time. It just takes time. Cos is x over r. X is negative 12. R is 13. And our last one, tan. Tan is y over x. Tan is y over x. Oh, sorry, guys. So 5 over negative 12 or negative 5 over 12. And those are our 3 trig ratios. I would like to know, and if you're embarrassed, you don't have to send it to everyone. You can send me a direct message, I don't mind. I want to know if you got 0 out of 3, 1 out of 3, 2 out of 3, or 3 out of 3. Nice. All 3. Woo! Superstars. Nondamiso, do you have a question?
Yes, ma'am. Ma'am,
Hi.
I wanted to ask the question, if they give us a question that says calculate the length of OP, is it a must to write units at the end?
It depends on how strict your teachers are being, but it's better to write units. Yeah.
Okay, thank you, ma'am.
Sure. Those of you who didn't get 3 out of 3, if you got 0 or if you got 1, remember you're here, you're putting in the effort, you're putting in the time, and that's what matters. It will get better over time. It's the first time you're seeing this, so don't be hard on yourselves. And guys, that is where we are calling it a night. We will keep it going on Thursday, and I hope you have a lovely week and only do good things at school, and we will catch up with you all on Thursday. I will give you a nice tricky one to start off our lesson on Thursday. I promise.
Guys, also remember, Thursday is quiz day, so please come prepared with your logins. I will send you guys a link and everything, but we're going to be doing a quiz at the end of the lesson. Thank you so much, Ms. G. This was so fun. I'm glad that everybody's getting it. Guys, don't forget to go and practice. It's really important to practice this stuff if you want to get it right. Yeah. And I'm loving your answers, guys. Your answers are like on point. Awesome stuff. Okay. Thanks so much, guys. We're going to see you guys on Thursday at 6 p.m. Okay.
Bye. Bye, everyone.